Hi Math 3 students, it's Mrs. Robinson here to work your first practice benchmark or your practice test for chapter 1. And this chapter was short, drawing conclusions from data. The first section is a review of mean, median, and mode, and you guys have done this since middle school, so it shouldn't be too tough. Let's get started. The first one, it asks you to find the mean, median, and mode for the set of data. So let's go through that. Hold on, let me get a pen. All right, when looking for the mean, median, and mode, the first thing you want to do, especially for the median, since we have to find that, is order these from least to greatest. So if you just go ahead and order these 1, 1, 1, and I like to cross mine off just so I know I've gotten them. Then it looks like there's a 2, then a 3, a 3. Next one looks like a 6, a 6. And then we've got 2 7s. And I apologize for the messy writing. It's really hard to work with this tool. And then a 15. All right, now that we've ordered them, first thing to find the mean. And you'll notice in this section, they teach you a little symbol for mean, and it looks like this. All right, so the mean is just the average. So you're going to add up all your values and divide by the number of values. There's 11 values here, so I'm going to divide by 11. If I just use a calculator and add all these up, I'm going to get 52, and divided by 11, I'm going to get 4.72, which I will round to the nearest tenth, 4.7. Let's go on to the median. The median, ooh, that's really hard to write with this pen. The median is the middle, and you need to order these in order from least to greatest just to see the middle. Since there's 11 values, there should be 5 on each side with 1 in the middle. So count over 1, 2, 3, 4, 5, and then this should be your middle value. Check it, there should be 5 on this side, 1, 2, 3, 4, 5. So my middle value will be 3. If there's an even number of numbers, you're going to take 2 middles, you're going to average them. All right, and let's look at the mode. Mode means most, or the number that occurs most often. And I'm going to go ahead and look at my numbers. I have 3 1s, and that occurs most often, so that's my mode. And there are my measures of central tendency. Let's go on to number 2. All right, guys, on number 2, I went ahead and paused it and wrote out all the values from least to greatest. And it's kind of tedious, so I just did it real quick. All right, from the least to greatest, and if you count out the number of values, there are 22 values here. So in order to find, I'm going to write the mean here. In order to find the mean, and you can do this symbol for the mean, you're going to add up these 22 values, and I added them all up, and I'm going to get 1794, and I just did it on a calculator. And you divide that by 22. So the mean you should get from that would be 81.5. And you're going to round to the nearest tenth. The median, or the middle, there are 22 values. Since it's even, you're going to go to 11 on both sides. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is my 11th value coming from the beginning. If I go backwards from the end, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is my 11th value. So really it's the 11th and the 12th value. You're going to add these two together since it's even. You're going to add these together and divide by 2. And you can see the average of 84 and 86 is going to be right in the middle at 85. That's going to be your median, 85. And then your mode, or the most, the number that occurs the most. If I look at this, the only number that occurs 3 times is 99, so that would be my mode. So 3 people rocked this math exam. And there you have it. Okay, we're going to find the outlier in this set of data. In the past, you may have defined outlier as 1.5 times the inner quartile range, and that value above the third quartile or below the first quartile would define an outlier specifically. Here we're just going to look at an outlier that's substantially larger or smaller than the rest of the values, and you can do that by ordering them from least to greatest. So let's go ahead and do that real quick. So let's go 12, 16, 17, 18, This is just kind of tedious. 20, 21, make sure I get those, 22, and then 34 does seem like an outlier. See the difference between the values. From 12 to 16, the difference is 4. 16 to 17, the difference is 1. 17 to 18, 1. 18 to 20, the difference is 2. 1, 1. And then the difference here, 22 to 34, that's 12, 14. So to me, that difference is significantly larger than the rest. So I'm going to go with 34 as the outlier. All right, let's go ahead and look at box and whisker plots for this set of data. You need to find all your quartiles in order to make a box and whisker plot. So first, let's go ahead and order these least to greatest. It looks like we're going to go with 12, then 13, 13. Let's mark off our values so we don't forget one. We've got 19 next, and then 3 26s, and a 27. All right, we've got 1, 2, 3, 4, 5, 6, 7, 8 values. Since we have 8 values, our median is going to be right in the middle. It's an even number, so our median is going to be right here in the middle. 4 values on this side, 4 values on this side. Now, that median is going to be an average of the two middle numbers. So I'm going to add 19 plus 26 and divide by 2. I'm going to find the average. So the median is going to be right here at 22.5. That will be our median. Okay, now you usually don't use your median to find your upper value quartile or your lower value quartile. You don't count that as part of it. Even if this were an odd number and the median was part of your data values, you don't count it. You just use your lower values and your upper values to find your medians. For your upper quartile median or your quartile 3, you've got 4 values, so it's going to be right in the middle here. Now the average of 26 and 26 is 26. So this will be your quartile 3. This is quartile 2 or your median. And then your lower quartile will be the median of the lower half. There's 4 values. It'll be right here in the middle. So it will be 13, the same, because the average of 13 and 13 is 13. That will be quartile 1. Now we've found all our quartiles, and our whiskers go to our highest value and our lowest value. Our highest value is going to be 27 and our lowest value will be 12. So go ahead and sketch out a number line here. Let's go, let's start here at 10. We'll go 10, 15, 20, 25, and then 30. And if you want to go 10, 11, 12, 13, 14 and just put little ticks in between, because you like to be a little more accurate. I didn't put enough ticks in here. 26, 27, 28, 29, 30. Did I put enough ticks here? 1, 2, 3, 4. 1, 2, 3, 4. There we go. Okay, let's go ahead and plot our quartiles. So quartile 2 right in the middle is 22.5. So here's 20, 21, 22, 23. So it's going to be right about here. And I'm going to put a little line right through that. And I'm drawing this on a mouse, so it's really hard to make it pretty. So let's go here. Quartile 3 is at 26, which will be right here. That'll be the end of my box. And then quartile 1 is at 13, 15, 14, 13 right here. That'll be the other end of my box. And then I'm going to go ahead and try to draw a box out of this. Here we go. And there is my box. It isn't super pretty, but it works. Now my whiskers are going to go out to my upper value. So 26, 27, here's my upper value. And then my lowest value is going to be at 12. So I'm at 13 and here's 12. And there are my whiskers, and there's my little box and whisker. It's the blue, not the red markings. It's all the blue markings, and there's my box and whisker plot. All right, let's look at number 5. I just paused it and wrote out the values from least to greatest just for the sake of you not watching me do that because it's super tedious and boring. Go ahead and do that. Make sure you write them out least to greatest. I like to start and then cross off my numbers to make sure I hit everything. So there are 20 values here, which means it's even again. So you're going to count 10 from each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And make sure it's 10 from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th and 11th values in between will be your median or your middle. I'm going to go ahead and draw a little red line right here. 58 and 58, the average of 58 and 58 is 58. So the median or the middle is going to be 58. That will be quartile 2. Now your upper values, there's going to be 10 of them because we have a median here that isn't one of our values. So there will be 10 for your upper values. So you count over 5. 1, 2, 3, 4, 5. This way, 1, 2, 3, 4, 5. So between 60 and 61 will be your upper quartile. The average of 60 and 61 will be 60.5. That will be quartile 3. And then do it for your lower half. So you'll have 10 values, count over 5. 1, 2, 3, 4, 5. Count this way, 5, 1, 2, 3, 4, 5, if you prefer to do it like that. And then halfway between 55 and 55, well, that's 55. And that's quartile 1. Okay, now you can go ahead and do your box and whisker. Here's your lowest value. Here's your here's your greatest value, your uppest value, and however you want to call it. And let's go ahead and draw a number line. I'm going to try to use this little guy to try to make it a little straighter. So if we're going from 49 to 58, I'm going to start down here at 45. Let's go by fives. 45, 50, 55, 60, 65, and this is not totally even because I'm drawing it by hand, and then let's go up to 70. And if I want to go 65, 66, 67, 68, 69, 70, if I want to draw little ticks in between, you can. It's a little tedious. Hold on. All right, I paused it just so you don't have to watch me do that. Let's go ahead and draw our quartile 2 will be at 58. So 55, 6, 7, 8, somewhere right here. Did I make enough ticks? This is going to have to be 55. 1, 2, 3, 4, yeah. 55, 56, 57, 58. So that will be our middle. And then our quartile 3 will be at 60.5, between 60 and 61, so somewhere right here. And then our quartile 1 will be at 55, so it's going to be a tight box. Let's go ahead and draw that box. So this will be our median. This will be the top of our box and the bottom of our box. And you go ahead and draw your box. I'm going to draw that very pretty. And then you need your whiskers. Let me see if I can fix that a bit. All right, and then my whiskers are going to go out to the highest value, which will be 68, right here. And to my lowest value, which will be 49, right here. And there's your box and whiskers. And you can see the values are clumped right here in the middle for this one. And this one, they're much more spread out, and actually they're dispersed. You can see there's a lot more values spread out here, and in the upper part they're tighter together here because of all these 26s. So it helps you see the values doing that. Okay, in order to find the values at the 30th and 90 percentiles, you want to order your values once again. So let's order these real quick. We have 100, another 100, let's see, 105. This is tedious, so I'm going to pause it. Okay, here they are ordered from least to greatest. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values, all right? If you want to find the 30th percentile, you're just going to do 30% or 0.3 times 10, which is just going to be 3, okay? So at 30th percentile, you're going to find your third value, 1, 2, 3, here at 105. So this will be your 30th percentile. And what that means is 30% of the values fall at or below 105. Now let's do the 90th percentile. 90th percentile will be 0.9 or 90% times the number of values you have. You have 10 values, which is going to give you 9. So you're going to count over to your 9th value. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's your 9th value. So this is the 90th percentile, meaning 90% of the values fall at or below 176. This will be your 90th percentile. And this will be your 30th percentile. All right. All right, let's go over the mean, which is your average. And that symbol is the X. And then the variance is this little symbol, squared. And then the standard deviation is just this little symbol. And you sometimes will see the standard deviation of a certain value, X, whatever that value is. So if we want to find the mean is just, once again, your average. You're just going to add up your values and divide by the number of values. So if we add these all up, there are 1, 2, 3, 4, 5, 6. There are 6 values here. We're going to add those up and divide by 6. Go ahead and do that. And you're going to get 51 divided by 6, which is going to give you 8.5. So there's your mean. Now your variance. Okay, let's go ahead and find the variance. So it's sigma squared. And what that means is I'm going to find how the variance and the standard deviation let me know how far each of my values deviate from this mean. So first, to find the variance, I find the difference from my mean, 8.5, and each one of these values. So 8.5 minus 8, and then I square it. And that's going to give me 0.5 and square it. 0.5 times 0.5 is 0.25. There's my first value. So I'm going to do that for each one of these values. And this is another tedious task. I'm going to go 8.5 minus 4 squared. And then I'll do 8.5 minus 3 squared. And 8.5 minus 12 squared. And 8.5 minus 11 squared. And it's okay if this value is negative because I'm going to square it, it's going to become positive. Same here. 8.5 minus 13, and I'm going to square it. All right, so go ahead and calculate all these values. Okay, I went ahead and found all of these values, subtract this, square it, all of these values. In order to finish finding the variance, I need to add all my values together. So I found the difference squared for each of these. Now I'm going to find the average of this by adding up each value. And if I go ahead and add those all up, I'm going to get 89.5. And then I'm going to find the mean of this, or the average of this. There are 1, 2, 3, 4, 5, 6 values. So I'm going to divide by 6. And if I divide that by 6, I'm going to get 14.91, and I'm going to go ahead and round to 14.9. All right, so that would be my variance. Now my standard deviation is just sigma, which means I need to take the square root of this. So if sigma squared equals 14.9, I need to square root both sides to just find sigma. So I'm going to find the square root of 14.9, and that's going to give me 3.86, and that would be my standard deviation. So I now want to see how many of these values, how many standard deviations they are away from the mean. But there is my standard deviation, there's my variance, and there's my mean. Real quick, guys, on the test, if you have a value like this, round it to the nearest tenth. This would round to 3.9, and I'm sure you can figure that out. All right, let's look at number 8. All right, I'm going to add these guys all up and find the mean first. So the mean, or the average, is going to be, add these up, 1, 2, 3, 4, 5, 6. There are 6 values, so I'm going to divide by 6. Go ahead and do that. Okay, if you add all these up, you're going to get 449. Divide that by 6. You're going to get 74.833. That's a 4. or 74.8 will work. So there's your mean. Now to find the variance, you got to do all the work. You're going to subtract all these values from the mean and square them. 74.8 minus 84 squared. 74.8 minus 51 squared. 74.8. Oh, I put the point in the wrong place. Hold up. 74.8 minus 80 squared. 74.8 minus 90 squared. 74.8 minus 65 squared. And then I ran a room up here, so I'm going to put this one up here. 74.8 minus 79 squared. All right, I'm going to go ahead and calculate all of these values. Hold on. All right, working all these values, I get 17.64, 84.64, 566.44, that's a big one, 27.04, 231.04, 96.04. All right, now I've done all of I've subtracted the mean from each of these values and squared them. Now in order to find the variance, I need to add these all together and divide by 6. So I'm going to find the average of these. So add those all together, and if you do that, you're going to get I'm going to write it up here, 1022.84. That's all of these added together, all right? And to find the average, I'm dividing by 6, all right? And that's going to give me my variance. All right, my variance, which is going to be 170.47 or 0.5. There's your variance. Now in order to find your standard deviation, you're going to take the square root of the variance. So your standard deviation is just going to be the square root of 170.5. So go ahead and do that on a calculator. And you're going to get 13.05, and you could round to 13.1. Standard deviation here is 13.1. And there's your variance in standard deviation. It tells you how much these values vary from that mean. All right, let's go on to number 9. All right, number 9. Lucas keeps track of the number of tickets sold for each play presented at his school. Within how many standard deviations from the mean do all these values fall? So first we have to find the mean, then we have to do the variance to get the standard deviation and make a little map. So doing all these calculations are time consuming. If you have a TI calculator, TI-83, TI-84, the book does show you how to make inputs for this on your graphing calculator. If you don't want to do all those basic calculations, it shows you how to do that online, how to use this TI and what buttons to push. Something that I think is super easy to do, go to metacalculator.com, pull that up, and I'm going to share that with you right now. Hold on. All right, so if you go to metacalculator.com and pull up the statistics calculator, you can just input values and it'll find those values for you super quick instead of doing all the tedious calculations. So 91, let's go ahead and input this. 122, 109, 111, 73, 97. This is tedious. You probably don't want to watch me do this. I'm going to pause it. All right, I inputted all those values. Now I'm going to hit Calculate Statistics. And when I do that, I can see my max, my min range. It does the variance. It does the standard deviation. It does the mean. It even gives me my quartiles, my interquartile range, sum of squares and all of this stuff. We haven't talked about some of those things or statistics things, but let's go ahead and see. I can see here my mean is 111, my variance is 765.8, and my standard deviation is 27.6. You could round that up to 27.7. All right, so let's go ahead and write those values down. So my mean was, I still have it open in another window over here. Here is 111. My variance was 765.8. 0.8 about, and my standard deviation is going to be 27.67. We'll do 27.7. So if I want to know, let me get a little line out. Hold on. I want to know within how many standard deviations from the mean do all the values fall. So let's look. If my mean is at 111 and my standard deviation is 27.7, so I'm going to take 111 and I'm going to add 27.7, and that's going to give me the next standard deviation, 138.7. Let's add one more time. 138.7 plus that standard deviation of 27.7, that's 166.4. So this would be one standard deviation, one standard deviation. This would be two standard deviations. Okay, and then let's do in the other direction. We're going to go 111 and we're going to subtract off 27.7. And that's going to give me 83.3, so that would be one standard deviation. And then let's go one more time, 83.3 minus 27.7, and that's going to give me 55.6. So let's see where our values fall and see if they fall within two standard deviations. If not, I'm going to have to go one more on each side. Let's go ahead and look at our values. I'm going to do them in blue. All right, so 91 falls right here in this range. 122 falls in this range. So 109 falls in this range. 111 is right at my median. 73 falls in this range. Oh, I didn't write the two standard deviations here. Falls in this range. 73 falls in here. 97 falls in here. 120 falls in here, one standard deviation. 64 falls down here. 124, and this is tedious again, is here. 161, oh, nope, it's still in here. 113 falls in here. And then 147 falls in here. So all of my values fall within two standard deviations of the mean. So I would say within how many? Two standard deviations of the mean. All right, let's go ahead and go on to number 10. That's good. If it falls within 3 standard deviations, your data is really varied and spread apart. 2 standard deviations, it's a little closer together. So let's go ahead and look. Mrs. Mullen's English class scored pretty good on yesterday's quiz. With one exception, everyone received a B. Within how many standard deviations from the mean do all the quiz grades fall? So once again, let's go ahead and pull up our MetaCalculator, and let's clear off this. And I'm going to go ahead and clear these values out. All right, I'm back here at the MetaCalculator, and I went ahead and entered all of these quiz grades. They're all mostly B's. There was one A value, so I entered all 12 values. And now I just go ahead and hit Calculate Statistics. Come on, calculate. All right, and there is my mean. So I'm going to go ahead and circle that. My mean is 86. My variance is 12.62, and my standard deviation is 3.55. You could round to 3.56. So a tighter grouping of data here. Let's go ahead and work with that. All right, my mean was, and I just lost it. Hold on. All right, my mean was 85.6. My standard my variance was 12.6, and then my standard deviation, square root that, you get 3.5 about. Okay, so doing that, let's see where our values fall. If we go ahead and make a line, and I'm thinking this is going to be grouped pretty closely together. 85.6 is my mean, and one standard deviation up. If I did 85.6 plus 3.5, I get 89.1, and then I'm going to have to do one more because I already know I have a value higher than that. 89.1 plus 3.5 is going to give me 92.6. Okay, and then let's go below 85.6 minus 3.5. One standard deviation below, I get 82.1. And let's go one more. 82.1 minus 3.5, that's going to give me 78.6. And I can see that's where they're all going to fall. My highest value was 92, which is going to fall in here. And my lowest value was 80, which is going to fall in here. So I can see already without placing all the values, my highest value and my lowest value fall within, here's one standard deviation, there's one, and here's the second standard deviation, there's two. So all my values are going to fall within 2 standard deviations again. All right, on to number 11. All right, number 11, students ask every third person to walk into the student union to walk in. It should say who walks into the student union, what their favorite color is. Which type of study method is described in each situation? Or in this situation, I should say. All right, so it's not a controlled experiment. That's where you would break into 2 groups and you would control one with the placebo and whatnot. Observational study, where you wouldn't interact with the person, you would observe what's going on in its natural environment. This would be a survey. They literally are surveying students as they walk in. All right, so I would say A for this guy. Come on, A. Let's look at 12. Researchers randomly choose 2 groups from 19 volunteers. Over a period of 12 weeks, one group watches television before going to sleep and the other does not. Volunteers wear monitoring devices while sleeping and the researchers record dream activity. Which type of study method is described in each situation or in this particular situation? So this one would be not the observational study necessarily, because that's where you wouldn't affect their normal environment, but you are. You're not surveying them. You're doing a controlled experiment. You give one group monitors, well, all the volunteers, but one group watches television and the other doesn't. So you're controlling one group by having one activity and another group doing another activity. So that would be B, controlled experiment. All right. Okay, the scores in an exam are normally distributed with a mean of 81 and a standard deviation of 6. What percent of scores are less than 87? Okay, I tried to draw a normal curve. I know it's not very pretty because it's hard to control this mouse. So a normal curve, 34% on each side or 68% of the values fall within 1 standard deviation of the mean. So if the mean is 81 and 1 standard deviation away, the standard deviation is 6, so 87 would be this value, and 81, 75 would be this value. All right, so that's 1 standard deviation. Now under a normal curve, 13.5, this would be a 13.5% would fall within the next standard deviation, 13.5%. Okay, so on each side. So altogether within 2 standard deviations, 95% of the values fall. And within 3 standard deviations, you're going to get like 99.7%. So the 3rd standard deviation in a normal curve would give you another like 2.35%. 2.35% on both sides. Okay. So what percent of the scores are less than 87? 87 is 1 standard deviation away from the mean. So from here, this way would be the percent that's less than 87. So add up those percents. You have 34%, 34%, 13.5%, and 2.35%. All right? That's the percentage that falls, that's the percent of scores that are less than 87. So add those up. Okay, if I add these up, I get 83.85, which you would round to about 84%. So if this falls within 1 standard deviation, 84% will be below it. All right. Let's go ahead and look at 14. A grocery store will only accept tomatoes that are at least 3 inches in diameter. A grower has a crop of tomatoes with diameters that are normally distributed, just like this. okay, with a mean diameter of 3.5 inches. So let's use my normal distribution curve that I already drew up here. And now we're going to say our mean for the tomato that he grows is about 3.5 inches in diameter. Okay, so he wants them to be at least 3 inches. So his mean is 3.5. That's good. It has a standard deviation of 0.25. So to the next level, 3.5 plus 0.25, and I'm going to get 3.75 for the first standard deviation, and 3.5 minus 0.25, and I'm going to get 3.25 below or above, all right? What percent of onions will be accepted by the grocery store? They have to be at least 3 inches in diameter, at least. So it's the smaller ones we're worried about. So let's take 0.25 off again because it's a standard deviation of 0.25. So the second standard deviation would just be 3. And from there, I'm going to take 0.25 again to get to the third standard deviation. I'm going to get 2.75. Okay, so from here, I have a 3.25 and then I have a 3, but anything below it's not going to accept. So I want all of these percentages up here. I don't want anything below here. So we just add up all these percentages. I want the tomato to be at least 3, which would be here in my normal bell curve. My normal distribution curve, I should say. So all of these values and above. So I'm going to add up 13.5% should fall here, 34%, 34%. So all of these will work, all of these will work, all of these are going to be bigger. I don't even have to see what these values are. I know they're bigger than 3. 13.5% again, and 2.35%. So go ahead and add that up. You're going to get 97.35, which you could round to 97.4%. They're going to accept 94% of the tomatoes, and now they're onions, apparently. So 94% of them the grocery store will accept from this point up. Okay, the bar graph shows the rents paid per month for apartments in an urban neighborhood. The curve shows that the rents are normally distributed. That's a hard word for me, apparently. So that means the mean's going to be right here somewhere. All right. And if you look at that, this line would be your first standard deviation. This would be your second standard deviation. And this would be your third. So if it's normally distributed, 34% would be here and here. This would be 34%. This would be another 13.5%. And this would be like 2.35% or something like that. Okay. Estimate the percent of apartment residents who pay less than $600 per month. 6 to 649 is here, so 600 would be right here. What percent pay less? Remember, in a normal distribution, 99.7% lie within the first 3 standard deviations. So from here below, you have 2.35%. You actually have a teeny bit more on each side. So here I would say the percent of residents that pay less than 600 is a very small percent, 2.35. Maybe you could round that up a little bit to 3%. All right. All right, I went ahead and drew a normal distribution curve for number 16. The number of dog biscuits in a shipment of boxes are normally distributed with a mean of 57 and a standard deviation of 3. So 3 up, 3 down, each side. I went ahead and wrote the percentages under a normal distribution, 34% on each side, so 68% within one, 13.5% to the next, and 2.35% to the next. I know the writing is really ugly, and I apologize for that. That's a point there. So, all right. What percent of dog biscuits will contain between 54 and 60 biscuits? Well, let's see. If it has a standard deviation of 3, to the first standard deviation, 57 plus 3 will be 60. And the first standard deviation below, 57 minus 3, 54. So looking at this, we want to know between 54 and 60 biscuits, what percent of boxes of dog biscuits will contain this amount? Well, between 54 and 60 biscuits lies within one standard deviation. So 34 plus 34, or 68% of boxes. If it's normally distributed, 68% of the boxes should contain between 54 and 60 biscuits. And there's your answer. All right, let's look at 17. Over the first 5 years of owning his Jeep, Chet drove about 12,000 miles the first year, 17,753 miles the second year, 12 the third year, this many the fourth year, and this many the fifth year. Find the mean median mode of this data. Explain which measure of central tendency will best predict how many miles Gina will drive in the sixth year. So let's find the mean median mode. Looking at our values, let's write them in from the order of least to greatest. The smallest amount that he drove was 11,550. Then he drove 12,000. Let's see, 12,650. 13,400, and then 17,753 that year he drove a ton. The mean is the average, so add them up and divide by the number of values. So 1, 2, 3, 4, 5. So the mean is going to be this value. Add those all up and divide them by 5. So go ahead and do that real quick. So add those all up, you're going to get 67,353 divided by 5. It's an approximately 13,470.6 or 471. Right, there's your mean. Median, you'll find the median, which is the middle number, and that's just going to be 12,650 because I've written these from least to greatest. And the mode, or the most often number, there isn't one that repeats, so there's no mode. Now in this case, it's going to be the median or the mean, the mean or the median that would best represent. And I'm going to go with the median in this case. And the reason is this number is awfully a lot higher than the rest of these. It's an outlier. And when you have an outlier, it affects your median, your mean. It affects your mean, your average. So when it affects the average, you need to be careful with those outliers. And the median would be the best value for how many miles she'll drive next year. So I'm going to go with the median for that reason. And that's what you would write down. The outlier skews the mean. All right, let's talk about survey questions here. And some of these questions are a little tricky. Is there any bias in the survey question? Are you offering a leading question, trying to get people to answer it a certain way? So let's read this one. I want you to choose yes or no and explain your choice. What do you think would help students pay more attention in class? Does this survey question have a bias? What do you think would help students pay more attention in class? I'm going to say no, there's not really a bias here. It's a pretty straightforward question. There wasn't a leading question. For example, if it said something like, what do you think would help naughty students that can't sit still pay more attention in class? So that's inferring that students that don't pay attention are naughty. Or some kind of leading question that implies some kind of bias towards somebody that you like or don't like, or something you prefer or don't prefer. So that would be a biased survey question, where you would get a certain response because you put certain words in there. This is a pretty straightforward question. All right, so do you think there's any bias? I'm going to say no, it's pretty straightforward. Let's go on to number 19. A large company that manufactures light bulbs selects 3 bulbs each day at random from the thousands manufactured each day. These bulbs are tested to see how many hours they last. That's supposed to say hours, how many hours they last. Should the sample statistics be used to make a general conclusion about the population? All right, so I took a sample. They take samples of 3 bulbs at random from the thousands manufactured each day. Do you think this sample could be used for the general population of light bulbs? Well, if they manufacture thousands each day and they only pick 3 to test to see how many hours they last, not house, that's not very many. That's a pretty small sample size, super small. So I'm going to say, should the sample be used? I'm going to say no. It's a small sample size. And it might not accurately represent the thousands of light bulbs they manufacture each day. They might just have picked 3 good ones. If they manufacture, say, 10,000, maybe they want to pick a few more than 3 to test. So I'm going to say no, the sample size is pretty small. All right, last one, number 20. A food product company is researching new artificial sweetener. The company asks 100 people, all from a retirement home, to rate the taste of the drink on a scale from 1 to 10. Half the people from the home were given tea sweetened with sugar, and half the people from the home were given tea sweetened with artificial sweetener. So that's a controlled experiment. Then the results from each group were averaged. So the sweetened group and the sugar group, and they averaged the results. So should the sample statistics be used to make a general conclusion about the whole population? Well, was there a bias to it? Is the sample size too small? What do we have here? I'm going to go with no. And the reason I choose no is they did 100 people and they only asked people in a retirement home. So the reason I'm going to say no is the people in the population that they surveyed are going to be generally older than the general population. Okay. So it might not accurately represent the population's taste as a whole. Everybody can have different age groups, might have different taste likes, okay? Not accurately represent whole population. And I'm just writing this super shorthand because it takes forever to write with this mouse. So I would say no, just because they didn't survey a random group or a large group from all different walks of life or all different choices of age groups. A retirement home is the only people they surveyed. So I would say no to that question. All right, guys, that's it. Email me if you have any questions, and have a great day.